The center of symmetry is an imaginary center again inside the solid crystal inside. Where is that center? If you see this cube, where is the center? So this vertical axis going from center of the top face to center of bottom face. It goes vertical through the crystal, and there is another axis here going from center of this face, front face, to center of opposite face. These two axes will intersect somewhere inside the crystal. That is a point or the place where these two axes will intersect. That is the probable center of symmetry. If you check behavior of this axis, it goes in, again it ends up into the center and come back out, passing through the center. So this also goes through the center. This becomes axis of symmetry, which goes through the center of symmetry. So if you go to the center, imagine that you are at the center. If you look at these corners, that is solid angles, top solid angles, you'll find that from any imaginary center, these all solid angles, either at the top side or at the bottom side, are placed at equal distances. From the same imaginary center inside this crystal, you'll find that this axis from this point to other opposite face point. These two faces at this side and other side are placed at equal distances from imaginary center. This is cube. You can see here imaginary center of symmetry. From this imaginary center, all solid angles are at equal distances. All edges are at equal distances. So this becomes center of symmetry. This is another model of cube showing center of symmetry here, an imaginary center. If you intersect this vertical axis with this A1 axis, you extend them, they will intersect at the point of an imaginary center. This will also pass through, A2 axis will also pass through the center of symmetry. So this is a point of intersection of these axes. So this model reveals, you can see center of symmetry is present. All things are going to the center. All planes, all axes, may it be diagonal or axial, meets at the center. And here is the center of symmetry.